K values. Okay, K values we'll discuss in detail. Okay, so K values are five. There are 5 K values. Okay. This must match. All the K values must match, and the AS number must match. Then only ARGRP will form a neighborship. Okay. So ARGRP first creates a neighbor table. Neighbor table. Okay. Then from neighbor table, it exchanges the routes and creates a topology table. And from topology table, it selects the best route and put it into a routing table. Okay. First,
Okay.
I'll form neighborship. Then I will exchange routes, and the best route I'll put it into the routing table. Okay. So for that, we'll have a different topology. So let's start that topology and let's run the idea. Okay, so this is my saved labs. Okay, you can save the labs also, starting all the devices. Now we'll be working on this topology. All the devices started. Oh my God, initial configuration. So, so I have to stop and start. Okay, just give me 2 minutes. Why is this taking one minute? Give me, you know, just give me 2 minutes. Resolve it. Okay. So now, for now, we just see how ERGRP neighborship is formed between R1 and R2. Okay.
Okay.
They will send hello. Okay, on 224.0.0.0.10. That is their multicast address used by ERGRP. Okay. And hello has AS number. Autonomous system number is I have defined it here. What is an autonomous? It represents a common routing domain. Okay, a common routing domain. So to be neighbor, I have to be on the same domain. Okay, and which is represented by a number, which is known as autonomous system number. Okay.
Okay.
So I will use an AS number, let's say 100. Okay. And K values, I'll keep it as default. I don't want to change it. First, I want to explain what are K values. So I'll go on R1. Okay. R1. Okay. And let me just wipe out so I can see the network. R1. Okay. So I want to ping. So I don't ping the IP, I ping the broadcast address. Okay, with a repeat count of accidentally I pressed 5. I'll get 5 replies. I'm getting a reply from my windows. Okay, and their IPs. So I can run ERGRP now. How to run ERGRP is simple, like you do in your OSPF. It is router ERGRP, and the AS number you have to specify. So we have decided that we'll use AS number 100. So it is AS number 100. Okay. Then we have to advertise the connected networks. That is 10.1.12.0, and you have to use wildcard bit.
Okay. This is as OSPF, right? Yeah.
Yeah,
Okay.
I like OSPF. As goes. I told you, like ERGRP is a copy of little bit of OSPF. Okay. So it is same like that. Okay. Then let me check what interfaces I have. Do I keep interface brief? So I see I have 1.1 configured. 13 dot is also configured. Okay. Now I don't know the subnet mask. So what I'll do, I'll directly advertise the IP. You know, exact match, all zeros. Wildcard is all zeros. What does this mean?
So okay.
What does
So
it mean?
so just the host, this last 32.
Yeah. No. It's not that. No, it says that, yeah, host IP, it's an host IP. Yes, you are right. It says that first octet exact match 10. I won't allow 11. Second octet also match as 1. Okay,
Okay.
1 is allowed. Third octet 13 is allowed. Fourth octet 14 is allowed. Okay, but on R2, what we did was 10.1.12.0, right? And we said 0.0.0.255. Correct? So it says the exact match 10, exact match 1, exact match 12, but this can be any value between 255, 0 to 255.
Mm.
It means that. Okay. So this is much stronger, like this is stronger. You're exactly advertising the routing, the network which is on the interface. Okay.
Okay. Okay.
So you can use this. This is the best practice to run ERGR. Okay. So I'll use this, and then I'll use even for one. I'll use all zeros. Okay. Now let's go on R2. I can go on the router ERGRP 100. And suppose in exam they ask you use a single command. Now let's see, do show IP interface brief. So I have three interfaces. Okay. So I need actually three commands, right? Network commands. But Cisco is asking me in the exam that use a single command to advertise all these networks. Use a single command to advertise all these networks. So what we can do is we can advertise a default network.
Okay.
Okay. You say just 000 or 0. That's it. And you can see our neighborship has come up and you have become the neighbor. Okay.
Okay.
So now let's jump on to R3. Okay. Here I won't use the default one. Promise key, router ERGRP 100, okay. Network 10.1.13.3. I know all the networks now. Network 0.3.3.3.3. Network 10.1.34.3. Let me save it. Let me save it. Right. Okay. You can use two commands, either write memory, or simply write, or you can use copy run to start up.
Yeah, to start up. Okay.
Okay. It's one and the same. It will get saved. You say write memory also, you will do the same. Okay.
Okay.
Then I go on R4. Let's see so IP interface brief. Okay. So I have many networks here. Okay. So no problem. I'll advertise all of them. In one command, I can do that, but I don't want to do it. Okay. I'll do commands. Network 10.1.23.4. So 24.4. Because it will be between router 2 and 4. Okay, 34 and network 4.4.4. Here I can use that because I don't want to know the mask. Okay. So I don't know the mask, but I'll advertise the IP directly. 3.4 and 3.4. And let's jump on R1 and let's check the show IP. First, you have to check your neighborship. Show IP ERGRP neighbor is the command. Okay. So this is what you will see in your table. Okay. There are two neighbors. 13.3 that is router 3. 12.2 that is router 2. Okay. On which interface the neighborship is up. Okay. Whole time and hello time we'll discuss that. Okay. From how many it is been up. Okay. This is smooth route trip primer. You know how many seconds, milliseconds did I take to form the new ARGRP neighborship? Okay, and RTO is not that request timeout; it's a different value. But don't worry about it. You have to just worry about this queue count, query count. It is known as query count. Okay, and each neighbor has a sequence number. Okay, query count is it should not be there in your routing table. Okay, if it is there, then there is some problem with your routing. Some error is going on with the routing. Some
But
error.
so that flag CNT So for what is the purpose of this flag? Is to check if there is a routing problem on the path.
Yeah,
Okay.
you need to check the routing problem.
Okay.
Okay. There is queue count. In short, it is QCNP. Queue count.
Okay.
It must be always zero. Okay, just remember that. If you have queue count in see in large ERP network, you may find it. Okay. In large ERP networks, you may find it queue count increasing. Okay. So this is how you advertise ERP in 3 ways. Directly, you can advertise the network. One minute.
Okay.
Please. We are going mad or sit here. Okay, I'm back. So 3 ways we can advertise the ERP network. So first we see the ERP neighbor table. Okay. In the neighbor table, you will find ERP neighbors. Okay. On which interface they have become the neighbor. Okay. This is your ERP neighbor. Okay. Then you have ERP topology table. Okay. In this, you have all the routes with different paths and all. Okay. And there is a dual algorithm is calculated. Okay. And you will see the best path in the routing table. Okay. So this is your ERP routing table, which is denoted by D. Okay. Represented by D. D means ERP. Okay. This is your administrative distance, 90, and your cost metric. Okay.
Okay.
This is your metric cost. Okay. And this is your administrative distance. Now ERP has two administrative distance. One is 90 and one is 170. 90 is for internal routes, means route learn in the same AS number. External means route learn from the outer, some protocol or some redistribution command. Okay. That
Okay.
is
External means from other routing protocol like script. Okay.
other
Okay.
routing protocol or other ERP AS process.
Okay.
So okay, so that can be done, right? You can use two ARP or two, three, four process also on a single router. That's not a problem like BGP. BGP, you can run only one AS on a router, right? But not in ERP.
Okay.
So ERP sends hello at 224.0. You can check actually, by debugging it. Debug IP ERP packets. Neighbor, okay, so